Dear students, let us begin the third part of this lesson, in which you will be able to understand the importance of studying the testing the hypothesis for one-tailed test. Students, the critical area of distribution in a statistical test is of two types. One is one-sided test, another is two-sided test. Choosing whether to perform one-tailed test or two-tailed test is one of the important methodology of decision making for statistical analysis. One-tailed and two-tailed test. There are three kinds of problems arises in testing the hypothesis that may include two-tailed test, right-tailed test, left-tailed test. One-tailed and two-tailed test. In a two-tailed test, the null hypothesis about the population mean is rejected for the value of x bar falling in tail of the sampling distribution. When the hypothesis about population mean is rejected and only for the value of x bar falling into one of the tails of the sampling distribution, this is known as one-tailed test. If the test is left tail, then is one-tailed test or one-sided test alternative to the left. For example, H0 mu equal to 100 tested against the H1 mu is greater than 100 or less than 100 is a one-tailed test, since the alternative hypothesis H1 specifies that mu lies on a particular side of 100, that is either greater than or lesser than. Hence, we talk here about null hypothesis tested against H1 mu is not equal to 100 is a two-tailed test, since mu can be on either side of 100. If it is one-sided test, then it is either greater than or lesser than a certain value, but not both. In other words, the sampling mean would be greater than or lesser than the population mean. Here, testing the possibility is done only in one direction, one-tailed test. The critical value of t at the level of significance alpha and degrees of freedom for the one-tailed test are defined as follows. The significant value of t at any level of significance alpha for a single-tailed test, it may be either right-tailed or left-tailed. It can be obtained from those of two-tailed test by the values at the level of significance to alpha. One-tailed test. Since t distribution is symmetric about t equal to 0, we obtain the values as probability of t is greater than t of the nu comma alpha plus probability of t less than t of nu comma alpha, that is equal to alpha. The nu is nothing but the degrees of freedom, alpha is the level of significance. So, we can have 2 times of probability of the corresponding value, that is equal to alpha. So, probability of the particular value is equal to alpha by 2. So, we get the probability value that is equal to alpha. Hence, the 2 alpha gives the significant value of t for a single tail test. The values are given by Fisher and Yates table, that is, it may be either right tail or left tail, since the distribution is symmetrical at level of significance of alpha and nu degrees of freedom. The level of significance may be 5% or 1%, which may be decided by the researcher. T table. Looking at the T table, one can find the rows and columns for the one-tailed test. Rows represent the significant level and a column represent the degrees of freedom. For instance, in the left side of we put degrees of freedom, which we have 1, 2, 3, 4, 5 for 5 samples, and the corresponding one-tailed test is given here, that is for 0.05, 0.025, 0.010 and 0.005 for one-tailed test. Similarly, for two-tailed test is given by 0.10, 0.05, 0.02 and 0.01. Suppose, for example, we have taken a sample of 5 with 5%, the corresponding table value is 2.015. For example, when t equal to 8, 0.05 for one-tailed test and t of 8, 0.10 for two-tailed test, the value is 1.86. Similarly, for another example, we see t with 15 degrees of freedom at 1% level of significance for one-tailed test, and t of 15 degrees of freedom and 0.02 for two-tailed test, the value is obtained as 2.60. Example, let us consider a right-tailed t-test is being conducted. The critical value needs to be calculated for alpha level. Then the steps are as follows. Subtract the alpha level from 0.5, that is 50%, that is 0.5 minus 0.0079, that is equal to 0.4921. By using the t-distribution table, find the area which is closest to the 0.4921. The closest area is 0.4922 as obtained from the table value. So here we have intersection of 2.4 and 0.02, thus the t critical value can be defined as 2.42. Students, let us summarize what we have learned in this video. In this video, we have learned about null and alternative hypothesis in testing the two dependent sample means, the test statistics, critical value with suitable level of significance, and types of test, assessing the one-tailed test in two dependent sample means. Students, hope you understood the concepts which are discussed in this video, which may be helpful for your research. Thank you.